found a part with the number 5307. It was a simple bolt, but for them it was impossible. You are on the Eastern Front. A battered Willis Jeep, a prize of war, is dragged into a German field workshop. The mechanics, true masters of their craft, begin to take it apart. They expect a puzzle, a machine built with the unique touch of a human hand, where every part is filed and fitted to its one-of-a-kind home. This is how you built a Panzer, a Mercedes, a masterpiece of German engineering. But this Jeep, this was something else entirely. They take that bolt, number 5307, from the engine block. They walk over to another captured Jeep, seemingly identical. They find the same location. The official report, sent back to High Command, states what happened next. The bolt from the first Jeep fit perfectly into the second. No filing, no adjustments. It just worked. Now, think about what that means. To a German engineer, this was witchcraft. Their own parts were individually fitted by artisans. A piston from one Tiger tank would not fit another without being remachined. It was a point of pride, a signature of quality. But the Americans weren't signatures. They were an army of millions of identical pieces. This concept was called interchangeability. The Germans had heard of it, of course. The theory wasn't new. Eli Whitney had famously demonstrated it with muskets back in 1801. But to see it applied to something as complex as a vehicle engine on a scale that defied imagination, that was profoundly unsettling. The reports sent back to Berlin were filled with a strange mixture of admiration and alarm. They documented how American soldiers, with only a few weeks of training, could salvage parts from 3 broken trucks to build a working fourth. In the middle of a muddy field, in hours. Your master mechanic, with his 20 years of experience, was suddenly less effective than a 19-year-old from Ohio with a wrench and a manual. The German High Command saw a technical curiosity. A few officers, however, saw something far more dangerous. They saw a new philosophy of war. A philosophy rooted in logistics, the ability to produce and repair faster than the enemy could destroy. At the Ford Motor Company's Willow Run plant, a B-24 Liberator bomber rolled off the assembly line every 63 minutes by 1944. An entire 4-engine heavy bomber in the time it takes to watch a film. This wasn't just manufacturing. This was warfare waged by the factory floor. The Germans believed they were fighting a war of quality against quantity. But what if the Americans had discovered something else? What if they had figured out how to turn quantity into a quality all its own? Their secret lay not in individual craftsmanship, but in a relentless pursuit of standardization. In 1901, Henry Leland, founder of Cadillac, demonstrated this concept. He disassembled 3 of his cars, mixed the parts, and then reassembled them. The cars ran perfectly. This was a challenge to the entire automotive industry. This wasn't just about cars. This was about a fundamental shift in how things were made. You see, the German approach, honed over centuries, favored bespoke engineering. Every engine was a work of art, a testament to the individual skill of its maker. Think about the pride in a master mechanic's hands, each part filed and fitted. But what happens when that part breaks? That's where the German system faltered. They needed another master, another artisan, and those were in short supply during wartime. Consider this. A single Focke-Wulf FW-190 fighter plane required approximately 40,000 individual parts, each one crafted with meticulous care. Now imagine needing a specific cam follower for its BMW 801 engine. You'd need one made specifically for that engine, not just any cam follower. This created a logistical nightmare for the Luftwaffe. Their repair depots were overwhelmed. Their planes were grounded. Contrast this with the American system, a standardized cam follower. It fits every BMW 801 engine. This drastically reduced repair times. it meant more planes in the air. This concept, known as interchangeable parts, was not born overnight. Eli Whitney in 1801 proved muskets could be made this way, but it took decades for industries to fully adopt it. The German military, despite its technological prowess, largely resisted. They saw mass production as a compromise, a sacrifice of quality. A report from the German Ministry of Armaments in 1942 highlighted this internal conflict. It stated, "The American method of production, while lacking the precision of German workmanship, achieves an overall reliability through mass interchangeability." This was a grudging admission. They still couldn't quite grasp its full implications. You, as a German engineer, would have seen the flawless fit of American parts as an anomaly, a fluke, not a deliberate design philosophy. You'd have been trained to prize precision above all else. The idea that a slightly less precise part could be more effective due to its availability was alien. What was truly astonishing was the scale. The Americans were not just standardizing small components. They were standardizing entire subassemblies. A complete engine block, for instance, could be swapped out in a matter of hours. This was unheard of in German factories. They would rebuild an engine piece by piece. This difference in philosophy had profound consequences on the battlefield. When a German tank broke down, it often stayed broken for weeks, maybe months, or it was simply abandoned. But an American Sherman tank? If its engine failed, a new one could be flown in, installed, and the tank back in action within a day. This was not just about better parts. It was about a better system of war. Albert Speer, Hitler's Minister of Armaments, recognized this disparity late in the war. He tried to implement American methods, but German industry, steeped in its traditions, could not adapt quickly enough. The ingrained culture of individual craftsmanship was too strong. They simply could not shift their entire manufacturing base. Imagine the frustration. You see the enemy's advantage, you understand its power, but you cannot replicate it. The very foundation of your industrial strength, your pride in precision, had become a weakness. It made them inflexible. It made them lose. But what if the problem wasn't just about manufacturing? What if it was about something far more fundamental, something that touched the very soul of German engineering itself? It was a philosophy of perfection, of bespoke artistry. But this very strength, this pursuit of individual excellence, became a profound weakness when confronted with the American method. Think about it. You're a master craftsman. You've spent decades perfecting your skill. Then someone tells you that your handmade, perfectly fitted component is inferior to a mass-produced piece that fits everything. This isn't just about manufacturing. This is an attack on your identity. A German engineer from Daimler-Benz, Dr. Ferdinand Porsche's assistant, once remarked in 1944, "The American method, it is efficient, but it lacks a soul." This tells you everything. They understood the efficiency, but they couldn't grasp the underlying cultural shift. The system itself was foreign. The German system relied on highly skilled individuals at every stage. Apprenticeships lasted years. Mastery was revered. This created products of unparalleled quality, yes, but it also created bottlenecks. A single missing expert could halt an entire production line. It made them fragile. The American system, however, was designed to be robust. It was built for scale. It was built for resilience. It was about processes, not personalities. And here's where it gets really interesting. The very concept of system of systems originated in American thinking. You might think of it as a giant machine made of smaller, interconnected machines. Each part, each subassembly, designed to work seamlessly with any other. This was not just about bolts and engines. This was about logistics, about supply chains, about training, and ultimately about a different kind of war. General Motors, in 1942, was producing M4 Sherman tanks at a rate that dwarfed German Panther production. One GM plant alone, Fisher Body, was churning out tanks at a pace of one every 90 minutes. A German factory, a single Panther, took weeks. This wasn't because German workers were. It was because the German production system was fundamentally different. It was less adaptable, less interchangeable. German factories were often smaller, more specialized, each producing a specific component, often by hand, then assembling it. You can see the problem, can't you? If one specialized factory was bombed, the entire chain broke. The Americans, with their interchangeable parts, could shift production. If a Detroit plant went down, a plant in California could pick up the slack. The parts would still fit. This was a war of industrial ecosystems. The German engineers were bewildered by the American ability to produce complex components in massive quantities, all to the same precise specifications. A report from the Reich Ministry of Armaments, dated March 1943, describes their efforts to reverse engineer American aircraft engines. They found that the tolerances, the allowable variations in size, were often looser than German standards. Yet, the engines worked. Reliably. This went against everything they believed. It challenged their core engineering principles. They were taught that tighter tolerances meant higher quality. But the Americans proved that consistent, standardized tolerances, even if slightly wider, allowed for vastly greater production and interchangeability. This was a paradigm shift. It was not about individual perfection. It was about collective reliability. And now pay attention to this. The American system wasn't just about manufacturing physical parts. It extended to human capital too. The German army relied on highly specialized, long-trained soldiers. Panzer crews spent years together, becoming intimately familiar with their specific tanks. This bred incredible loyalty and skill. But casualties meant losing irreplaceable experience. The American Army, on the other hand, trained soldiers to operate any tank, any rifle, any truck. The individual was interchangeable. You could replace a driver from Ohio with a driver from Texas, and the truck would still move. This was a brutal but effective truth of modern warfare. The Germans found this dehumanizing. They saw it as a lack of respect for individual skill. But for the Americans, it was about maintaining operational tempo. It was about winning. The numbers are stark. By 1944, the United States was outproducing Germany in tanks by a margin of nearly 4-1. In aircraft, it was closer to 5-1. These weren't just numbers. These were thousands of vehicles, thousands of aircraft, all built with interchangeable parts, all easily repaired, all keeping the front lines supplied. The German High Command, despite their initial dismissals, eventually understood the gravity of this difference. Albert Speer's desperate attempts to implement American methods in 1944 were too little, too late. German industry, rigid and tradition-bound, simply could not adapt. Their pride in craftsmanship, once their greatest asset, had become a chain. It bound them to a past that no longer existed. They were fighting a 20th century war with 19th century industrial thinking. The American way, with its focus on systems, standardization, and interchangeability, was more than just a manufacturing technique. It was a new blueprint for victory. But what if this blueprint, so effective in war, had unintended consequences for peace? Indeed, carried unforeseen consequences into the fragile peace that followed. You see, the very efficiency that won the war also began to reshape society itself. The industrial might that churned out tanks and planes now sought new markets. What do you think happened when factories built for war turned their attention to consumer goods? The answer lies in the sheer volume. This wasn't just about making things faster. It was about making more, a lot more. The focus shifted from durability to disposability. Imagine a master craftsman, proud of his work, now told to design something that would break in a few years. It was an assault on their principles. This is the hidden cost. This shift from repair to replacement meant that the average lifespan of many products began to shrink.
A toaster, once a lifetime purchase, became a temporary convenience. This change wasn't accidental. It was engineered. The concept of planned obsolescence, designing products to fail, gained traction. This was an economic strategy. It ensured continuous demand. It kept the factories running, and it kept the profits flowing. But it also created a new kind of waste, enormous mountains of it. The environmental impact of this accelerated consumption, this endless cycle of buy, break, replace, is something we are still grappling with today. Nobody asked if the planet could sustain this pace. The drive for efficiency overshadowed everything else. The immediate benefits were undeniable. Cheaper goods for more people, a booming economy, a sense of prosperity. But at what long-term price? The German engineers, who once marveled at American interchangeability, now faced a different challenge. They too began to adopt mass production techniques. Their own industries, re-from the ashes of war, had to compete. The old ways of bespoke craftsmanship became a luxury, a niche. The mass market demanded the American model. This wasn't just about economics. It was a cultural transformation. The individual, once valued for their unique skill, became a cog in a larger machine. Think about it. The soldier, interchangeable. The factory worker, interchangeable. The parts they made, interchangeable. This was a system built for scale, not for soul. A report from the German Federal Ministry of Economics in 1955 noted the increasing adoption of American production methods. It highlighted the economic benefits, but it also subtly lamented the loss of traditional craftsmanship. The numbers speak for themselves. By 1960, West Germany's industrial output had more than quadrupled compared to 1948. A remarkable recovery. But with it came a different kind of product. Less unique, more uniform. This shift, born on the battlefields of World War II, continues to define our world. We live in a society built on the principles of interchangeability and mass production. From your smartphone to your car, the parts are standardized. They are designed to be replaced, not repaired. This creates a convenience we often take for granted, but it also creates a dependence, a reliance on a global supply chain. What happens when that chain breaks? The recent disruptions, from pandemics to geopolitical tensions, have exposed the fragility of this system. A single factory closure, thousands of miles away, can bring entire industries to a halt. The very efficiency that brought victory now presents a new vulnerability. The German mechanics, confused by a single bolt in 1943, were witnessing the dawn of a new industrial age. An age where the individual part mattered less than the system it served. An age where quantity became its own form of quality. An age that promised abundance but delivered a different set of challenges. And now we must ask ourselves, are we still fighting a war with the tools of the last century? Or are we ready to build something new, something more resilient for the future? We are masters of. The real question is what we choose to build with the blueprint we were given. You see, the principle of interchangeability didn't stop with Jeeps and bombers. It escaped the factory. It became digital. In 2006, Amazon Web Services launched a service called S3. It allowed anyone, anywhere, to